kind of weird to see me twice. I kind of avoid the mirror every day, and then guess what? I need to see myself this way. Hello, everyone. Good morning. I'm glad to be here. My name is Otavio Santana, and don't do it, Alina. And let's talk about microservice, Kubernetes, and a lot of buzzword that everybody loves to put in production, but in reality, no. Today, I will talk more about the tactic and strategies around software development. And to answer the question that everybody wants to know, how to read a successful software. Because everybody discussing that, I have my own consultants company, I work in several open source projects, and that's what everybody wants to achieve, right? Everybody wants to achieve a successful software. Why? Because nobody wants to work on weekends. Nobody wants to spend more time than necessary. And we have this kind of discussion every single time, every single country that I went to. And yes, everybody wants a successful application. Everybody wants a successful software. Oops. But how? How to achieve that? That's $1 million question, right? How can I measure that? I know there is data metrics that make my life awesome, but is that the right way? Is that the proper way to figure out these things? I mean, if I do a lot of tasks, does it make sense to define my successful application? I know. I get a better idea. Let's put more often application in production, because if I do this way, I will achieve a successful application. Or even better, we are software developers, right? So if I put a lot of code on production, therefore I will put more successful application. That sounds wrong, right? If you imagine ourselves, especially because I saw every single time around this, when the company that I went to, and so on, we as software engineers, we love complexity. We are a conference like this, we want to put in production tomorrow what we learned today. Okay, not tomorrow, tomorrow is Saturday, but Monday, we want to do something like that. But when you go in reality, you can see things like that. So this article comes from Forbes, where there is 16 obstacles to a successful software product and how to avoid them. And that's funny, because if you can see here, where my lightsaber? Come on. Okay, use your imagination. Right now I'm pointing hyper-focus planning design. Right now we spend a lot of time planning and designing things. And at some time we design, we planning, you define the architecture with new buzzwords. And at some time we do not get the client expectation. So we spend hours, days, weeks to achieve one thing that nobody wants. We spend a lot of time on that because we put complexity that we don't want to put. We usually have a poor collaboration between the product and the engineer team, especially because we usually do this mistake, right? You love technology so much that you imagine that, okay, that technology is the end. However, it's a failure process. I mean, even to us who create developer experience to frameworks, things like that, if you only look to the product itself, the technology itself, it's a failure ring. Why? Why that? Because developers want to deliver the product that's not aligned with the client perspective. It's not only me, it's Forbes. And I guess everybody in the room got any kind of mistake like that. Why? Because it doesn't matter. I mean, if you are senior, if you are staff, if you're a principal engineer, you usually need to do a job that nobody wants to do. Probably some entry level come to your room or your Slack and talk, hey, I have the solution. And to solve that issue, I will use your imagination here, JavaScript, Java 20, Hibernate, Kubernetes, to solve these issues. On reality, this person does not care about the problem itself. They only care about the technology. They want to learn a new technology. And every time that's happened with me, and that's funny because I have right now I'm running a consult company as the sync engineer, and basically every month I have a discussion with a team, and they discuss things like that. Hey, Otavio, we are running this product to over 3 years. Nobody in the team knows how does it work because the team left, and it's hard to maintain, it's hard to read, it's not scalable. And guess what? We want to solve this issue. Okay. This makes me happy, right? Okay. I want to solve this issue as well. And then, okay, let's rewrite the whole application, the whole system, using new technologies. But how can I make sure after 3 years, new people will come in saying, hey, we got a new problem here because everybody left. And right now, to solve this issue, we need to rewrite with new technology. And of course, it's expensive to rewrite the application every single time, every 3 years. It's a nightmare to us. It's a nightmare to the company itself. It's spend time, it's infrastructure costs, and so on. And usually, when I got in that situation, I start to asking myself, do we really understand the term software engineering? Because if you go only the etymology, sorry, I love history. Yesterday I spent my whole day on museums. I know it's a boring stuff, but I love a lot. And engineering comes from Latin. That means be clever to create some things. The methodology is not the end, like the aqueduct over here. The goal is not to put some metal, some iron. The main goal is to move water between places, to make sure that the city has enough water to their infrastructure. Okay? And as any kind of engineering, we have two parts. We have the strategic, and we do have the tactics, right? The strategic is the goal, is where you want to do, is where you want to go. And the tactic is to get things done, and that is it. So the sample here, it was Julius Caesar who decided to cross the river to attack the Europe. You know that better than me, right? And he got a mission. They need to cross 4,000 soldiers as fast as possible. And they decided to create a bridge, and only for 10 days. The goal was not to put wood in the water. The goal was to move the troop. If the bridge become more expensive, they could use some boats, some ships. It doesn't matter the technology, the methodology. The main goal, the strategic, was move soldiers on 10 days. And why did I say that? I don't know. It's a useful information, right? I just love history. But anyway, let's talk about software engineer here. That's why we are here, right? I know there are several definitions of software engineer. This one here is my favorite by David Farley from Modern Software Engineering. That is, software engineer is the application of empirical. Yes, you should have experience, you should have know, and mix scientific approach to find efficient economic solution to solve a problem in the software. On the Julius Caesar issue, if the bridge costs more than cross the boat, probably they will use the boat instead of the bridge. Okay? The efficient way is the point. I mean, if my cost to create a software is bigger, it will have an issue with my ROI. Okay? If I have my issue with my ROI, it doesn't make sense to build a software itself. Once I say that, in software engineering, we also have the definition between strategy and tactic, where we usually go to architecture around the strategic, okay, the main goal, to go to understand what's going on, to design, to drawing, and the design to get things done. Okay? I know architecture has a lot of definitions. I know that, and a lot of those definitions come from just enough soft architecture, clean architecture, soft architecture, and fundamental soft architecture, and so on. But if you imagine, if you go, especially on this one here, the basic fundamentals of architecture, they have two laws of soft architecture. The first one is the world's not perfect, right? Everything that you decide to put has trade-offs. Okay, let's use Java. Java has trade-offs. Let's use Spring. Spring has trade-offs. Let's use relational database. Relational database has trade-off. NoSQL as well. And of course, the why. The reason that we're doing that is more important than the how. It's the two laws from soft architecture, and it has a huge alignment with the golden circle from Simon Sinek. Should I pose like this? Whoa! Mind blowing. Okay. And that's the main point. Another book that I love so much is the Philosophy of Soft Design, where they had a definition around strategic and tactical in the code. Okay? As you can see in this graph here, of course, if you go to the tactical way, you can get things done, but you don't think on the long-term support. Especially because as fast as you're going, put things that you don't imagine, you're going to do mess in the code. You're going to lose scalability inside your code. In the opposite way, when you do more strategic, okay, it might spend more time to write code, to write documentation, to write tests, make sure that everybody's on the same page. However, in the long term, it will be faster than the tactical. And usually, when you do software, we think, at least we should think more than 1 week and 1 month. I mean, as open source person, I'm guiding the Java community as the OpenJDK, and the OpenJDK has more than 25 years. A single software product, the goal is to be 25 years old, or even more, 27 right now. And the goal is to keep it, because if you decided to every 3 years rewrite the whole JVM, it'll be impossible to keep it going fast. I know you probably will complain, no, Otavio, it's not too fast this way. But we'll try to do our best. And from this book, we also have the definition of the tactical tornado. What does that mean? Is a person who wants to do things as fast as possible. And why tornado? Because everything that he taught in the code, nobody's able to understand anymore. It's like magic. And we have a definition here. Every team has a tactical tornado. If you don't know who is in your team, pay attention to that, because probably it's you, okay? But usually we have one, at least one who try to think first, fast, and they just forget about the strategic and the tactical way. And let's go to a polemic discussion right now, because everybody talks about the DDD the whole time, the domain-driven design. Why not? DDD here, DDD over here, because DDD is a framework, right? No, it's not. DDD is a way to communicate and to translate software, your domain, to software. That's why we have two partners inside DDD. We have the tactic and the strategy, where we should start with the strategy. Why? Because the why is more important than the how. Remember the two rules or two laws of soft architecture? The why is more important. That's why we spend time to understand what's going on. That's why we spend a lot of time to define the ambiguous language inside of system. Because the same words might have different meanings, like light, or I don't know, I don't have any idea than light. But we have the bounded context. We also have the context map. Based on that, you can go easily to convert the domain to code. And finally, you can convert that using partners like entity, value object, service, repository, and aggregator. I usually see this mistake around repository, where the idea, the repository by the book, supposed to get away the database logic to get closer to the business self. For example, if I have a rent car and I have a car empty, my collection or my repository of car is supposed to be a garage, right? Because my collection of car is garage. If I'm driving an airplane company, my collection of airplanes is supposed to be airport or hangar or something like that. However, every single place that I go, I usually go car repository, airplane repository, and so on. And sometimes people do not understand the difference between repository and the data access object, because it's like they did not understand the strategy behind the software itself. So remember that even DDD has the strategy and the tactic to implement this way. So understand first what you're doing with ambiguous language, binary context, and context map, and then convert to a software. There are several books. My recommendation is the Learning Domain-Driven Design. And documentation. I know everybody loves documentation, right? I mean, why not? It's so much fun to write documentation in my code. And of course, nobody wants to do it, but it's important. It is scalable. Every time they discuss about scalability inside the software, we need to talk about documentation. I guess everybody went to a product that asked the question, where is the documentation? And somebody raised their hand, okay, documentation, so yo, I am the documentation. But it's not a good idea, right? Because if this person left the organization, you're gonna left the knowledge inside the organization. Of course, if you do a lot of documentation, as everything, it has trade-off. So if you do a lot of documentation, the documentation will become more enemy than ally. You don't want to do that. However, if you don't do documentation, it's a go horse. Let's face it. If you don't cover documentation, this person left, or something goes wrong, you have no idea because the knowledge left the organization with this person. So, as anything in the software architecture, we need to imagine the trade-off. Okay, over documentation is not good. The documentation will become the enemy than the ally. But of course, if you don't have documentation, it's a blind software architecture. Okay? So the fair one is the one that you should achieve. Okay, I guess I don't convince you about documentation because it spends a lot of time. And how much is it gonna cost to your organization? Be honest, I don't know. I can say how much is it gonna cost if you don't do that in several contexts. For example, who knows the history around the Nice Saga, the finance company? Okay, if you don't know about this, because probably he bankrupted in 45 minutes. So in 45 minutes, they lost $416 million. So if you ask to that company how much cost the documentation, they will answer $406 million in 45 minutes. Okay. I have no idea how much is that. I mean, maybe I can buy my country. I'm from Brazil, by the way. But what happened was a lot of people left the organization. It's happened more often than we wish, right? The documentation is, yo soy la documentación, I am the documentation, left the organization. They put several dead codes. A lot of people decide, okay, why this code is commented? I get an excellent idea. Let's put this code in production. Because once it's working in my machine, it will work in production, right? It's an amazing idea. And they did exactly like that. And then one server in the cluster was not being updated, and then nobody knows how to procedure. The developer starts to crying, and every minute The company was lost in $1 million, until uh, they bankrupt the company in 45 minutes. It was pretty fast. And okay, hopefully I convinced you about documentation, but when we talk about documentation, we have several ways to do it. And of course, in the strategic way, let's start with the tactic because it's close to the code. So code documentation, change log, it's a file, the README file, and if you do have a REST API that everybody wants to do right now, use documentation of the API itself, like Swagger. And there is this book here that I love so much, where they said where the documentation has a client, and the client is another developer. So make sure the client is happy with documentation that is in the product itself. I usually discuss about documentation, and everybody usually raise their hand like, okay, Otavio, I don't need documentation in my code because my code is perfect. It's not code. It's a poem. It's like an amazing book. But let's face, the biggest successful open source product has documentation. The most successful products in the world has documentation. Why not you try to do the same? I mean, the idea is not to comment the obvious thing like, okay, let's comment the getter. Oh, he's a getter. Or let's create a constructor. Hey, this is a constructor. Guess what? It works to build something. Of course, no, but please put the reason that we're doing that. Link the class with the domain. Put some ambiguous context inside the code. Explain the reason, something like that. And README. Why do we need to have README and repository? Because I'm not Jedi. I cannot read minds. So every time that you decide to create a repository, please explain why do we need to pay attention to that repository. Put a short description. Every repository should have a goal. So why I'm doing that, remember the why is more important than the how. And put a guide how to start. And of course, API overview. For example, if you are creating a Maven product, put how to install. Okay, you need to use that dependency or Gradle this way. If you are defining an API, okay, explain a little bit how to use it, and so on. Another documentation is the change log. So the idea of change logs is pretty close to the README. Nobody's able to understand your mind, to read your mind. And, okay, I need to see what's going on. The changelog has a summary, what's happened by version, and each version has a type. So the main goal of changelogs is for humans, not machines. So the type of change, and of course, the latest one, you go in the top. Okay, everybody, I guess, when you talk about commits, is one way to understand what's going on. And if you are like me, you probably put something like WIP, work in progress, and someone needs to understand what's going on there. My advice, one thing that we're doing in the Eclipse Foundation and the open source world is the universal commit track that comes from the Angular, where I start with the type. So like, if you're gonna fix something, I put fix, or if I will do some change in my code, fit. If something is related to build, sure, to any modification that is not directly in the code. For example, I will include some Maven dependence, sure. CI, like GitHub Actions. Documentation, I know you don't like it, but it's important. Style is more around, okay, I need to align, put some space, remove some space, and so on. Refactoring, the name is good enough, I guess. Performance and test. Okay, remember this. So the type, if you want to include the scope, okay, like the organization, like the area, and then the description. The description should be a command, like create a new user entity or refactoring, optimizing the code, something like that, like a command. So you are doing something, it's a command. So do a step-by-step track with commits. So right now everybody will be able to see what's going on and commit by commit. Okay, let's go to the strategy. As I mentioned to you, strategy in the software, in the documentation, is to document the architecture. So we have 4 ways here for documents. We have the C4 model, where it's like a Google Maps, where you're able to see the zoom in and zoom out of your architecture configuration. The tech radar, I guess everybody faces the situation where somebody put some technology to try to get a new job. This person got a new job and he left with a technology that nobody knows what happened. So you can avoid this kind of mistake using the tech radar. ADR, architecture decision record. So any decision on the architectural perspective should be record. Why? To make sure that you're not gonna do the mistake twice. Of course, we're gonna do mistakes, but why do it twice? Let's avoid it. So ADR and a clear communication. I guess, come on, we are working in a company. Probably you face a situation where we went to a meeting that could be easily an email. So C4 model, the map, tech radar to technologies views, ADR to document the architectural perspective based on trade-off. For example, if you're gonna use Cassandra as NoSQL database, I need to make sure there is an issue because I need to make sure that everybody understands how Cassandra works. Otherwise, it will be a nightmare. Are we aware about that? Documented. So we decide to use the technology based on what you believe, even nobody know about that. Because if it was a mistake, it can use, okay, there is a new document database, but we saw what happened with Cassandra. Nobody knew about that. How can we avoid the mistake twice? Okay, let's do a training. Let's invite some experts to avoid the same mistake twice. And clear communication. The C4 model, I guess, is familiar for most of you guys, or is a documentation based on C4 or C. The first one is the context, the main reason that you're doing that, the C1. The second one is container. It's a Docker. It's not about Docker, but the application unit. The C3 is the components where you can use like the layers inside your applications, the integration between them. And the last one is the code, where, remember, the documentation should be an ally and not an enemy. I usually go into C3, and when the product is starting, I go into the container. One thing that I love is to use those tools, the C4 model builder or a structurizer, especially because I can convert documentation as a code. This way, I can use the GitOps philosophy because my Git is my source of truth. To ADR, remember I said the decision records, we are using Log4Brains because each architecture decision has a life cycle. For example, when decided to use Java 11 as the default one, it was valid until last year because it was deprecated. Because right now, we have a new decision record to use Java 17 as the default technology. So we are keeping updating that. And as any architecture decision record, we have a flow. So I will propose something, I will open APR, remember, Git as source of truth. We have a discussion to make sure that, okay, if it will be accepted or not. If it will be accepted, eventually it can be deprecated. It's happened, right? So I'm using SQL or I'm using NoSQL and then decide to reverse this situation. And we have the decision log. There are several ways. My favorite one so far is with log4brains because I can see the log decision. They are this flow like this. So it's like a visual idea. And when I talk about documentation, my advice for you is make sure that documentation is accessible by links. So that is the DocOps idea. So the documentation use Git is available in the source directly, and I should be able to access the documentation use browser easier as possible. Why? Because if there is one thing that people hate more than write documentation is read documentation. So if you make it difficult to access, they will don't use. So try to use a browser. So if you are using Markdown with Git, you can use Hugo or you can use Amazon S3 and so on. But make sure the documentation is easy and accessible. And once you do a merge of this new documentation, it will run a deploy and follow the cycle of operation. Okay, I talked too much about documentation, and let's go to the second one, most favorite thing that we love to do, that is tests, right? I mean, when we talk about tests, we usually talk about quality, and we know that the coverage is a good metric, but it's not enough. One thing that we are doing right now is to combine those. So we are combining the test coverage with mutation tests. If you are a Java developer, you can use the Peters org. It's consumed a lot of time to process. The idea here is to make sure that your test is being effective to run this kind of thing. So I love a lot the Peters because I find out that we had 100% of coverage, but at some time we are not testing more than 30% of the application. So the mutation will try to do a mask inside your code to make sure that you are testing what it's supposed to test. In your test, we are using, everybody's moving to Jupyter, and we are combining J5 with AssertJ because AssertJ has a nice Fluent API. So you can use several ways. Of course, I just have a few minutes. I'm not able to do live code here. But anyway, I'm going to show a link where I can cover it a little bit more. This one here is more over the tactical, so it's mostly in the code perspective. But as you know, the tactic is not enough. So you can go to the strategic on the test. Right now, we have a lot of QA. But our culture, we decided to move everybody that is QA to become a QE, quality engineer. The idea that everybody is able to code, to write code, to test code, so understand the code. And of course, this classic one by Matt Fowler, we need to have a lot of unit tests because it's cheaper, it's more easier to do, it works like a documentation as well. But it's not enough, right? We have isolation here. So we need to make sure that everybody is able to test and work pretty much very good. Okay, I talked about the strategy and tactical around soft architecture, the documentation, the tests, and let's talk about the awesome thing that everybody's talking right now, cloud. Because if you go to the cloud, there is no way that you're going to do a mistake because everybody's moving to the cloud, right? There's no way to do mistake around that. However, if you go to the reality, it's not so true. Almost the companies are overspending using cloud. And that's happened with my company itself. So we saw that we're spending much more money using cloud than anything else. And HashiCorp did these requests. And there's one here from info Flexera that say this waste is around 35%. So we are wasting 35% of the cost because we decide to move to the cloud. Not everybody, but almost everybody is wasting money and time because of that. And in the technical perspective, there is no there is no doubt. So ops to everything, and we put a strong culture of finops inside the organization to avoid. Okay, not every team has their budget to make sure that they're gonna save the money properly. Uh, Friday at 8 p.m. we shut down the whole servers. Of course, no production, but the staging and locals we are shut down, and we restore it at Monday. And it saves a lot of money. I mean, when we decide to just do that, we save around 2 million euros to each team. So it was okay. We are a bank, but even a bank don't want to burn money like this way. So just doing a small things like this, we saved a lot of money. And when we talk about strategic on service, we need to understand that okay, not everything we need to follow the orb. It's happening with cloud. We love to make jokes around cloud is somebody else server, cloud is I issue to something, but for me, cloud is a little bit more than somebody else computer or server. Cloud is somebody else's problem. I mean, if I don't have knowledge to do something, like I don't have knowledge to handle with Kubernetes, I can pay somebody else to handle that for me. I can pay somebody else to focus on that issue where I'm focused more on my business perspective. There is this amazing book here, 97 Things Every Cloud Engineer Should Know. And okay, those are super valuable tips. Just to highlight two, use managed service when it makes sense. Okay, you know Cassandra, you know Postgres, but when something gonna happen on production, make sure that the people who knows is available to that. So if you do this way, we delegate the issue to somebody else. And the second one, to make everybody calm down around the Kubernetes idea, it's okay if you're not running Kubernetes. And when I say that, not locally. So if you have Amazon, there is several ways to use Kubernetes with automation and things like that. And when I talk about application on the cloud, make sure that you are following the classic, the 12-factor application, and you are combining that with the GitOps culture. I know we're gonna lose the amazing joke around, okay, it works on my machine. It's a bad news, right? But at least you make sure that everything on your organization is trackable, is reversible, and observable. And when I talk about this, I'm talking about everything. I'm talking about documentation that I can reverse. I'm talking about infrastructure that I can reverse. I'm talking about code itself. So have an amazing culture around GitOps. So make sure that everything as possible, the technical perspective, is nearby Git. By the way, the documentation that I mentioned to you is trackable by Git because of that. In the 12-factor application, I will highlight just two. The third one is the configuration. Credentials, you should not put in the code. It sounds like obvious, but OSP, the security organization, said that 75% of the application has any kind of code vulnerability around the configuration. So, so even if you believe it's obvious, make sure that your organization believe that as well. So check this third one because, again, 75, 3 or 4 application has any code vulnerability with configuration. Make sure you are the last one. And another point is the infrastructure configuration. Why? Because there is an issue report around database that they saw that a lot of database servers were with public IP and with the default password and user when they have. So if I find any kind of race database or Apache Tomcat, if I put root 1235, I have a huge chance to access the critical system of our entire organization. And that is too bad, right? And of course, when we talk about cloud strategy, remember, focus against control. Why I'm saying that? Because, okay, I want to do on-premise because it's cheaper this way. But cheaper does not mean long-term support. We are spending a lot of time to maintain this kind of thing. If you go to another service like serverless or things like that, or platform as a service, you're gonna save time because you're gonna pay somebody else to handle that for you. So, as I said before, everything in the architectural perspective has trade-offs, and the cloud is not an exception. Use that. And that's the main goal for today. Talk about the strategy and tactical around software documentation. Again, I have 5 minutes left. But of course, your root is the context. You need to make sure that, okay, Otavio, you're talking about non-user Kubernetes. My organization is entirely building Kubernetes. So if it makes sense to your context, go for it. But use documentation to make sure that you're not going to do the same mistake twice. Understand that the reason that we're doing the software on the architectural perspective, because the architectural perspective is the strategy behind the code, behind the software itself. And a mistake that we usually do as a finance area, we usually have a room with the architect's rooms, but it's become like a deprecated. So I don't believe that the architecture should be exclusive just to senior people or more experienced people. I guess everybody should participate on or understand what's going on there. Of course, with moderation by the more expert inside the team. Doing code design, DDD, documentation, cloud, and tests based on the context. That's everything for today. And remember, the reason that we have the discussion is because right now we have a huge complexity. Everything become with a huge complexity. If some random reason, we feel safe because of the complexity. And right now we have a huge amount of tools that's supposed to make our life easier, but right now our life become more difficult because we have a lot of tools. A single hello world that I did on university like 10 years ago, right now it looks like an integration with Kafka, microservices, ChatGPT, and things like that. So a single hello world become more complex. Not because we should do, because we have more options. It's hard. We have a paradox around choice that everybody here might be familiar. For example, myself. Sometimes I spend 1 hour to choose a movie on Netflix, and then I fall asleep in 10 minutes. So I spend more time choosing the movie than watch the movie itself. And it's happening with software development right now. So make sure that you're using the proper tool to the proper moment. And last year, I went to the Da Vinci Table, where I love this quote. The simplicity is the ultimate sophistication. Yes, he was not there. He was unpolite with me. But anyway, I give a rose, hopefully when he's back. And I guess it's become like kind of way to finish any kind of presentation around architecture, right? And kind of code documentation, because when we started, we tried to do as simple as possible because we have no idea how to do it. And then we start to learn design patterns, and then you try to put strategy in every single piece of code. We try to put composites in every single point of code. And then we realized that it's become much complex this way. And then we return to the simplest code as possible. Because as Leonardo da Vinci said, the simplest code is the ultimate stage of sophistication. Okay, yeah, you got that after some years. So if you are a beginner, take this spoiler. So do code simple as possible. And that is myself. So Otavio Santana, Java champion, Oracle Ace. I'm JSP, so I'm working Java since Java 8. I'm doing my best. Sorry if it's not good as possible. I'm a Apache committer, Eclipse committer, so Cassandra, database, Jakarta, and so on. And I receive a lot of awards like Duke Choice, JCP awards. I write books. And yes, I don't have social life because I don't have friends, so I use my free time to do some technical things. But anyway, thank you, and hopefully you enjoy, and we have a few time to questions. And of course, each topic here has more details. I will share in the link in Twitter, so follow me, and you can discuss more about history or something not related to software. And thank you, everybody.